Welcome back to another episode of the Block Runner Podcast. I'm your host, William, always here with your co-host, Iman.
What's going on, dude?
And on the sticks, we got TJ.
Hello.
And joining us today, finally, we got Landon Wang, the creator and founder of Moss. Thank you for joining us, man.
Yeah. Hi, guys. Nice to see you.
Yeah, nice to meet you too, man. We're going down this rabbit hole of AI exploration, right? And our community introduced us to Moss.
Yeah.
And we have a little bit of a history on this channel of like people from the community just, throwing us suggestions as far as like ecosystems or different projects we need to kind of like look into because there's something potentially substantial brewing there, right? And a good example of this would be Vitensor and Tau. Our community was pinging us pretty early of like, you guys, 2 years ago, you guys need to look into this. This is a very unique cross section between crypto and AI. But now, the AI market, the AI agent sector, it's becoming pretty hot and a very large percentage of the mind share, specifically in crypto, right? So if you can, I know you have a very deep and extensive background, per our research, a couple of decades, at least in the interest of this AI research. But if you can kind of give us your origin story of, what your beginnings are in the AI industry and how you got yourself into this Web3 crossroads of AI and crypto.
Yeah. For AI research, I think that's a very long story. Yeah. But it just became very simple reason. I just need to have finished some credits. Yeah, for my master degree in computer science. And I have interest in AI and especially artificial neural networks back to 2 decades before. And I went I joined the class, artificial neural network, and I met a professor, and he said it's quite easy to publish a academic paper, research paper in artificial neural networks, because it's it was quite a hot research topic. So I attended the class and take the course and start to implement my first artificial neural networks. So that's where the story began. Yeah.
Yeah, so in our research, we saw that you've been working on neural networks since about 2004, which you released a paper, and so it's interesting that now that you're getting into kind of the Web3 space, and you have a Moss token, and you're also combining this artificial intelligence with a 3D metaverse. So if you could go into like the Moss token and talk a little bit about like the metaverse that these agents are participating in?
Yeah. So actually, we started the metaverse back to 2021. And that's by the end of that year, we launched a metaverse called Moss AI. Yeah. So at the beginning, it's not just a particular for AI project. That's a metaverse project. Yeah, we have thousands artificial islands generated by AI, and to form a world, islands world. Yeah, so that's where we began. Yeah, but at that time, I designed this metaverse just using generative AI. More specifically, we use StyleGAN to generate the image of the islands. Yeah, and then we start from those 2D image to create 3D islands model, and then we create a lot of NFTs and more. We can have some avatars. Yeah, we call it. Yeah, we even use some real one player, this kind of avatar. Yeah, in our metaverse, and we have a fully decentralized architecture and driven by generative AI. So that's the original idea. And then from that beginning, we involve our architecture, including the infrastructures. Yeah, for example, the GPU computing layer, yeah, layer 3 blockchain to what we have right now. Yeah.
So that decentralized architecture you're describing, that is the Hyper AGI network. Am I correct? And is that what's supported by the HYPT token?
Yes.
Okay.
At the very beginning, we call our token not HYPT, but we call it the super smart dust. Yeah. Oh. So that's what the name of the foundation. We call that the hyper dust.
Hyperdust. Yeah.
Gradually we figure out how to develop, how to create this in architecture, and then we have a hyper AGI network.
So the beginnings of this infrastructure build was to support a decentralized metaverse before decentralized AGI, which now is like what I think, based on your website and all your material, that correct me if I'm wrong, it seems to be like your new focus, at least behind like what the Moss AI ecosystem is about, right? It's this idea of emergent properties from within these AI agents. Am I correct? So explain that original, that thesis, that concept, if you can, and then the importance of like a decentralized infrastructure like around that.
So the original idea of the infrastructure is also located on causal emergence. Yeah, just before I launched the whole metaverse, I just found a theory, yeah, called causal emergence. Yeah, and I think that's in 2021, yeah, also the same year, I immediately realized that this theory is just the last parcel of my theory, yeah, of self-involving software. Yeah, I call that aspect-oriented, neural network. So in design that infrastructure, I put AI, especially generative AI, in the first priority. Yeah, since I said we have those style GAN models. Yeah, and we plan to have those models involved and generating along the time, all the time. So we need a lot of computing power, more specific GPUs, to train the model. Yeah, at that time, not including large language model. Yeah, most of the model are just style GAN. Yeah, the GAN models, and so we figure out we probably definitely we need a decentralized infrastructure to support those AI. Involving down the road. So that's the idea. Yeah.
Landon, can you explain a little bit more about causal emergence? I know that in one of your diagrams, it talks about a causal engine. Do you want to go a little bit into what causal emergence is?
Yeah, sure. That causal emergence itself is not quite a new idea. Just back to probably 9 or 10 years, maybe not 10 years, maybe 8 or 9 years before. There is a paper, the idea proposed by Eric Cohen. Yeah, Eric Cohen is an American scientist in neural information system. Causal emergence the significant contribution of it is to propose an algorithm to calculate how and when the emergence happen, in a system. So that's the first time we have ability to predict, when the emergence happen. So that's quite unique, and I think that's quite the important, in our especially in complex system and the self-evolving system. And the idea behind that is to calculate the effective information of the system, and to see if the effective information is greater than particular value, and we call that the emergence happens in such system. So that's I put these very simple terms, but actually it's a little bit more complex than this.
For sure. What are the the conditional requirements, I guess, that an AI ecosystem such as yourself or any other, because there's a lot, right, that are just starting to kind of at least in the context of Web3, because this is a crypto channel. I know there's a lot happening beyond our walls in the AI technology paradigm, but the focus of this, I guess, discussion is more so like, how does Web3, cryptocurrency, tokenization, how do any of these primitives that is native to blockchain, how is this contributing to the crux of what the AI frontier is, right? Is discovering these qualitative emergence, these properties that can emerge. So what are the conditions AI ecosystems like yourself need to be providing? Is it more focused in the fine tuning of the AI agent frameworks themselves so that the agents become more productive? Is it more just we need more agents so that a higher population of agents like communicating with one another, it increases the probability of some sort of higher property emergence? Like, well, what is it in your opinion that's like the most important aspects to focus on?
Yeah, I think the most important thing is to have the system, the software has the ability to evolve by themselves, with the causal aspect. So I think that is more important. And of course, we are building an ecosystem to have more agents, working with each other, and eventually each agent will be an expert. We call that, a professional agent, and all the agents talk with each other and to form a collective, intelligence system.
What is that mechanism of achieving a professional agent? Like, how does one agent obtain like a specified purpose? Does that happen at deployment? And like, is that like a human is in charge and responsible for maintaining that progression to the point of like a professional status, or is it like you're saying, it's purely just a deploy agent and it's just a self iteration over time?
It's an emergence.
Yeah. Like, could you kind of break that down for us?
So as we're talking about the aspect-oriented, we, just like human or any intelligent system, we solve the problem. We call that in a system approach, we call the divide and conquer. Divide and conquer means if we have a concern or problem, we cannot solve it by suddenly entirely solve it. We just divide the problem into a sub problem, and conquer the sub problems, one by one. So that's the basic system approach. we call conquer and divide and conquer. Yeah. So we divide those big concern into smaller aspects. So we call that the aspects. Yeah. That's literally the aspects of a concern. Yeah. That's a sub part. That's just a part or a piece, a slice of the bigger concern. Yeah. So what we are doing is or causal machine, virtual machine doing is to figure out what aspect should be created. Yeah. And if we create this aspect, what's the benefit for the whole system? Yeah. If we calculate with this potential or candidate aspect to trigger the emergence happen, and we see, the system will, see, okay, this aspect is what we want, and make this aspect officially. And then the system involved by themselves. Yeah, so that's how it works.
Interesting.
We create more aspects, and all the bigger concern will be resolved by those aspects altogether.
Right.
Yeah.
So that is the value of having multiple agents, because each agent can take on a sub problem and then collectively solve the bigger problem.
Yes. Yeah. And this system approach we call the divide and conquer. So the divide and conquer probably is the most effective way to solve the problem, no matter what the problem is, that mathematically or politically, or economic problem. Yeah, we can always solve this problem by this way.
So let's run like a hypothetical simulation scenario, right? Because we have a metaverse interest and metaverse background ourselves. So, one of the biggest problems of the metaverse is actually building out a sustainable economic layer in the context of the digital space. It's a big problem. It requires multiple facets, so how would this system be able to approach this problem? Is it simply, give this agent swarm essentially the contextual understanding of human beings constructing sustainable economics over time, and then try to replicate that in the digital space? How would it actually manifest from identifying this root problem and these well-trained agents actually executing on something?
Yeah, I think we can give you. Yeah, I can give you a small example. We call the Stanford Tom or something like that. Stanford Tom. Yeah. Stanford Tom is a small town which has 25 agents, autonomous running agents. So all the agents talk with each other. So this is an academic research project, proposed by Stanford University group. Also, for Metaverse, and I'm working on this for years. So we will have, all these agents automatically, autonomously, living in this space. And all the agents, they have their own purpose, but the purpose is quite different. Maybe this, maybe that, but there must be some common purpose for all the agents, and even for all the human beings, and even for this world. I think about a lot about this. What is the driving force of humanity, of the world? What makes this world infinity?
Right.
The only answer would be emergence itself. Emergence itself driving the whole system, the whole world working. So, so you may ask why we need to make emergence happen. I don't know, but the emergence force is the force to push this world moving forward. Yeah, forever. It won't stop.
Right.
Yeah, for example, for humanity or civilization, the civilization itself won't stop. Only emerging. Yeah, to probably there's some physical principles behind of this, but from a higher system level, we saw emergence. Yeah, the emergence were driving. So in that sense, I even create an index. We call it the emergence index to for our metaverse before, even 2 years before. Yeah, I know. We will calculate all the emergence index of each island. Yeah, to see what's the contribution of this island. Yeah, or any particular user or particular agents to contribute to the whole system emergence. And then we distributed rewards. Yeah, it's what we are doing in reinforcement in learning. Yeah. So, but this is the last topic. Yeah, almost the same. Yeah, we just distributed rewards tokens to the most significant contributors of emergence.
Yeah, I find it interesting as well that we're starting to take the emergent property of humanity, and we're starting to apply it with artificial intelligence to solve, all different kinds of problems. And I understand like the value proposition of swarms, because now you can give a collective prompt to the swarm. It's like build an economy, and then the swarm will independently divide the different problems it would find about creating an economy, and the independent agents autonomously have purpose in solving their own little problem, so that ultimately you can form an economy within the metaverse. Now, my question to you, Landon, is when the prompt is create an economy and these agents go and do it, how do you give the swarm, do you give them explicit capabilities like being able to build in JavaScript or being able to create 3D models? Like, do you have to specifically give them that capability, or is that an emergent property as well?
Yeah, we need to have some key parameters of a whole system.
Okay.
Of an agent. For example, the agent should have the 5 capabilities. For example, adaptability, learning, the planning, and the memory, and other kind of stuff. And we even create 10 aspects to describe an AI agents. So we can always have those key parameters. Yeah, and start from those key parameters, and we can, for example, as I said, we can create a candidate a more smaller aspects. And even more. Yeah, for example, we can create 5 more aspects for as I said, the 5 key components or parameters. So, and then if, for example, we have to improve the perceive capability of agents in 3D world. So to achieve this, probably we will create or how to say trigger or is randomly or driven by the hypergenoid, as I said. Yeah, we have some presets. Preset requirement, and to explore the map of the island or space. And under this, in this aspect, as I said, this is one concern, probably higher level concern. And we even divide this concern, bigger concern, into smaller pieces. And then we figure out, the system will figure out to understand the map of the space, we need to, the system, one aspect need to be created to, to move forward, and backward and something, ability to explore the space and find the structure of the map.
So are you saying that that if you release an agent swarm in a 3D environment, and inherently, like, you and I can jump in as avatars and we intuitively know how to navigate just because we've spent time playing first-person shooters or whatever, but we can jump in and move around. Are you saying that these agents, once they're released in this environment, they can figure out how to move within this environment just by having just by being inside the world with like the same limitations as we have inside the world? Do they just figure it out, or do you explicitly have to train them as that this is a wall and, you know, you collide to it, and like how does that come about?
But for this particular scenario, we will create some primary knowledge. For example, an agent can move forward and for doves, it can move forward and backward and turn left, right. They have those capability.
Okay.
At the first place, and then they just explore, try out, to figure out the random map tree, this kind of thing.
Yeah, but the idea of the metaverse in context of like the complexity requirements for an economy, it's like, you know, now, say somebody has to develop like a commodities layer for a virtual environment, right? Meaning, you know, there's extractable digital commodities within this island or whatever, right? So
to mimic what happened with humanity 100 years ago with the Industrial Revolution.
Correct. That's to draw that parallel, right? If we give this AI the contextual understanding of how economics works, there's like a fundamental starting point to that, right? It's commodities discovery and utilization, right? And then you extrapolate further from there. It's the utilization of that, refining a commodity into some sort of new good, right? So that's like that's a new layer of complexity. Who knows what the digital architects end up building as far as like what these agents will actually need to do in this refinement process, right? So what is that mechanism of like, okay, I've created this application within the metaverse specifically where I need these agents to, you know, operate X, Y, and Z switches, levers in order for this commodity to refine into some higher, you know, valuable good. You know, what is it, like a new training module that some developer needs to kind of like plug into this Moss AI framework in order for all the agents to kind of have that new understanding of how to adapt to that environmental change? Like how's that going to work in the future?
Well, at the moment, our AI pod supports the space editing. People can or creator can rearrange everything in the space, and we unified all the spaces and even the web strip space. With our stand. We are at the moment we are using OpenAI's Geminism API. To describe the environment. The Geminism was invented for reinforcement, learning. So the agents observe the space described with the Geminism API, and as states of the environment. So then the agents will do some planning, processing, some calculation, and then take some actions. And those actions can can be applied, to those objects or environment and change the states of the space. And and then the agent will observe the change or modification of those the space or world states, and so that's a cycle. Repeat again. So in that sense, so people can create the environment, and the agent will adapt to the environment and make new actions.
So if you look into what NVIDIA is doing, they created this environment called Omniverse, and they're using it to train AI models, or specifically to train digital versions of robots in that environment, so that you can train it to, not collide into tables and things like that. So I'm curious, from your perspective. Go ahead.
The name of the NVIDIA simulation is called Isaac Newton Geminization.
Yeah, correct. Right. Yeah. So I'm curious, like, from your perspective, since we come from the metaverse and we understand the complexities of building out a 3D environment, and I'm curious as to why you used like a 3D environment for your agents. Like, why do that instead of just sticking with the 2D environment with applications and stuff? Like, what is your motivation behind using a 3D environment?
Yeah, I think that's for motivation. So just at the beginning of this project, we have a vision to involve the world from 1D, maybe that's DNA, 1D to 3D, to 2D, the imaging generated by GAN, and then 3D. So that's how a world evolved by itself, how our universe involved. So we are living in 3D or maybe 4D, spaces. So that's the original idea. And then we not stop at the virtual 3D world. We will blur the line between virtual and the reality, and come to the real world, by different technologies. For example, 3D printing, and even by simulation, robot simulation. We download agents AI to the robots in real world. And besides of that, I also wanted to mention the work, a little bit of the work of NVIDIA, between NVIDIA and API. As you mentioned, NVIDIA launched their solution already, they called it Omniverse. So at the very beginning, I used Omniverse, back to probably 2 years ago. But it's not quite easy to use, and it's expensive. Each floating license cost my $8,000. That's quite expensive. But at the very beginning, they worked with Unreal Engine, together, and I think that's very good choice or solution. It could be better, much better than right now. But I don't know why NVIDIA just created their own simulation platform. We already know that Isaac and Jim, this kind of a solution. But as I said, my vision or original plan is to create a 3D virtual 3D metaverse, and then we just move out from virtual to reality. Robots.
Okay.
So it seems that the utilization of a virtual environment is just a quick way to train AI agents with a similar environment that we exist in, right? Is to at least start the early training for that. Is that correct?
Oh, yes. Yeah, I think that's quite correct. Yeah. Even right at the moment, yeah, we have a lot of how to say experiments. Yeah, in Unreal Engine, we train and not only not just we, yeah, us, a lot of people, yeah, just do some testing in Unreal Engine to train their, for example, robotic arms, yeah, and those kind of things.
Okay. Okay. I think it's time to get a little bit deeper into the Moss ecosystem. And so, do you want to describe your ecosystem in the sense of you have the three tokens, and you have a token that supports agent activity and proof of useful work. So, do you want to go into you know how do you get into the ecosystem? How does it work, and what's the ultimate goal for this ecosystem?
Okay, let's talk about start with our three tokens. We have Morse token. I think that's a mini token. Yeah, we launched as a mini token. Yeah, but as you already know, we have our utility token, HYPT, and part of those utility token is pre-allocated, yeah, for agents. So, but where we how do we launch those agents? So, and we use Morse. Yeah, we use Morse token to buy or to trade to launch agents, and use Morse token to launch the loads. So actually, Morse token determine, yeah, whether and how fast the infrastructure, how many agents will be launched. So this we could call this Morse token as a governance, token. And for HYPT, I think that's for me that's quite obvious. Yeah, it's a utility token similar with Ethereum. Yeah, similar with ETH. So we use HYPT to pay the gas fee. Yeah, to drive more important to drive the loads to execute, to inference, or to render the agents. The agents at this point is quite similar with the smart contracts, yeah, on Ethereum blockchain. Sure. So, yeah, the idea is that, and the bytecode of the smart contract just like the code, aspect code running on our causal virtual machine. So that's the idea. And but since we have different layer, yeah, we have a infrastructure layer, and we have a AI layer, yeah, especially we have a large language model plus the causal virtual machine. So this is the AI layer. And so in some cases, yeah, the agents will not use our AI model. They can use some other AI model service or model provider. For example, they can use OpenAI, or they can use DeepSeek. Yeah, this kind of model. But the infrastructure works, yeah, for them. So we separate the third token. Yeah, we call it agent me. So agent me is a product, is a token dedicated for our AI model itself. So we call that HMB is IQ token. So yeah, so that's the whole setup of tokenomics. Yeah, and for the ecosystem as a whole, I think the agent itself, we will have a lot of agents, yeah, including humanoid agents, yeah, and even more huge number of utility agents. And all the agents, yeah, running on top of Hyper AGI network, on the top of infrastructure, and will leveraging the self-involving capability of our AI model, yeah, on top of custom virtual machine, yeah. So need a lot of each agents need to pay gas, of course, yeah, just like how smart contracts were working right now. So need a lot of HYPT, and for the most token, as I said, it determine control how fast, how many nodes we will create, how many agents we create. So that's just sort of like a throw, yeah, or sort of gas. Yeah, how if you push harder, the whole system run faster. Yeah, if you just so kind of a control mechanism over there. So that's basic idea, I think.
Yeah, you have this idea of a proof of useful work. How do you determine what is useful and what is not from the agents?
Yeah, it's a moment. For the, as I said, the highest standard or criteria on agents is emergence. Yeah, we can evaluate an agent contribution. Yeah, how much the contribution for the whole system emergence. So that's the first priority. But a lower level of creativity is proof of personhood. Yeah, personhood of an agent. Yeah, for example, an agent, self-aware or autonomous agents should be operating, should behave just like any intelligent system. Yeah, it will communicate. It is driven, yeah, by large language model. Yeah, that's so we need to generate tokens. So we have the token rates as a key index or parameter to evaluate the work of the loads. So that's proof of useful work. Yeah, finally, and from an AI point of view, the current, we can have those probably all the generative contents, text, image, video, or other thing, be tokenized. Yeah, all the contents will be tokenized. So token rates is just like the hash rate of a Bitcoin, and will become the key index of the proof of the work scale. Yeah.
So is there any like human validation required here initially, at least, just to kind of, because if the idea is
to tune what is good and what is not.
Yeah, because the idea here is if you're deciding or distributing allocation based on like a quantity of output, essentially, could that system be, I guess, taken advantage of, just like outputting spam or just nonsense as like a text output, right? Well, like who is the arbiter or the ensurer of like quality production, right?
Okay. So as I said, proof of personhood, including some criteria about the emergence. Yeah, not you cannot just generate some nonsense contents or text to cheat the protocol and to get the rewards. So the challenge, the difficulty will be increased. Yeah, for example, we will detect, we will calculate how much the value of effective information of your of the contents an agent generated to determine whether to give the rewards to it or not. So that's just like the mining difficulty, mining difficulty adjustment mechanism.
Yeah, that's interesting, because if you're using a difficulty to determine proof of, I guess, proof of like useful work, I think I could see that. I can see that working, because if they're able to produce something as a result of like doing that hashing power, then its output is mathematically provable, right? So I think that makes sense. I'd like to see like an example of that working.
Yeah, Landon, what is your position on like actual provable autonomy for agents? Because that's kind of like a boiling discussion right now.
Trusted execution environments.
Yeah, is that the golden wrapper to this to ensure like these agents are fully autonomous? Because like Truth Terminal right now, I guess some people assumed that was a fully autonomous AI, and then there's human beings like
doing transactions on their back end.
Yeah, tampering with that agent's wallet, right? So what is the actual authentic version of an agent that everybody can trust?
So is your question to ask how to make sure agents output is trust?
No, it's how do you maintain an autonomous agent that controls its own wallet and it doesn't have human access to that wallet?
Okay. I think that at this point, we do not have a very nice solution. I do not have 100% confidence to give an agent a huge amount of tokens or money. At the moment. So probably give them some gas fee or this kind of small money to them. And for cheating, or how to say, anti-fraud, anti-fraud. We definitely have more understanding on humanity. What's the good side of humanity and what's the bad side? And at the moment we do not have much more on the knowledge on that's part that maybe the dark part of humanity. And actually, I tried on solution provided by base chain. They have the multi-party wallet solution. Probably that's just for an agent.
Right, but do you believe that agents should have custody of their own wallet and not have like tamper-proof access for humans?
Yeah, is that part of the
design requirements for agents?
I think probably we should have those kind of how to say, in intelligence or understanding, humanity. It should have. Yeah.
I think that would be a necessary, like, conditional parameter set, right? Like an agent that understands it has its own verifiable mechanism of value accrual, I guess. So where now, if I think that kind of broadens the, I don't know, the scope of emergent possibilities, right? If maybe from this, you know, these agents can become more entrepreneurial in a sense, right? Yeah, like
so.
Yeah. Go ahead.
Just like let's imagine, let's imagine a civilization is more advanced than human. Yeah, but this civilization probably does not know how to cheat. Yeah, but maybe in a short time period, this advanced civilization will learn how to cheat, very fast by themselves. But if we have those, figure out how this intelligent system work, it should have those capability to learn how to cheat.
Yeah,
that's almost guaranteed to happen.
Inevitable
at some point.
Yeah.
But that's kind of the so is that what you would say is like the point of all this, like you know, pushing this I guess direction towards whatever the consensus around what AGI ends up becoming, what it is the point of arriving to that destination to find out what happens, even though we don't really clearly, I don't think anybody really knows the actual outcome of it. Is it more like it's a human curiosity angle? Like this is why we're all striving for this like inflection point? Or is it a clear destination where, you know, once we unlock something of an AGI where we could just almost infinitely produce AGI, it's the value outcome of that is incalculable, right? So it's something that we all should be pushing forward. Like, what would you say should be everybody's like motivation around the push for AGI?
Well, I'm not sure if everybody should have the motivation to push AGI. Probably not. Yeah, I don't think so. For those people already took the advantages, they do not want to let AGI happen. Yeah, especially in a decentralized way. If they can control the AGI, I think they have those motivation. But in my understanding, I don't think if the AGI can be controlled by somebody or groups, I don't think that it can be called AGI since it's controlled. Yeah, so it's not intelligent enough.
How many agents is a lot of agents? Like if you're talking about a swarm in the metaverse, how many is too many?
How to say? I do not have a specific number, but it depends on the resource. Yeah. The energy or economy. Yeah, this kind of
the reason why
constraint.
The reason why I ask is like I'm trying to understand what the bottleneck is for a swarm in the metaverse. Is it compute units per agent? Is it the infrastructure of the 3D environment hosting, let's say, 1,000 agents all at once? Like, you know, what do you see in the context of AI and agents in the metaverse? What is the bottleneck in terms of having, you know, billions of agents? Like, where is it? Agents each with their own wallet paying for their own compute from their wallet? Like, is that the bottleneck, or is there something else that I'm not thinking about?
Yeah, so I think sort of about this question, and I think we should, yeah, create some kind of emergence escape rates or escape acceleration. Yeah, just like the we have a escape acceleration or escape speed of the Earth. Yeah, out from Earth. So if the emergence happens in particular rates, yeah, we can call this system or metaverse and autonomous or emergent, yeah, system. It can keep the status of emergence. So in that sense, no matter how many agents you will have, yeah, it's only just about the emergence acceleration. Yeah.
So, but that's a function of your particular problem, the particular prompt of like a swarm, right? So, like for example, if the prompt is create an economy, and it's like here's your 3D environment, here's like you could build in this 3D environment using HTML and JavaScript, like, and you tell it to build an economy. It's like maybe you need 1,000 agents to do that because each needs its own discipline, and then you might be able to do it. Or maybe you just need 50 agents. And so when you say it depends on like the emergence, it's like if 50 agents is needed to build an economy in this metaverse and in this sandbox, then 51 agents is too much, is pretty much what you're saying.
Let me give you example scenario. If we have 50 agents, but all the agents just create some garbage content. Yeah, it is useless. Value. It does not have any value. Yeah, so we cannot call this metaverse or space as a sustainable system. Right. So they need to no matter if just one single agent can create some creative contents and nobody ever seen it before, and so we can call this metaverse or system sustainable system. It can make money, make values.
I see. And do you believe that the measure of sustainability is based upon how much value an agent swarm can create amongst themselves? Is that like the determining factor for sustainability?
But yes, exactly. Yeah,
okay. That's fair enough. Yeah, we tend to agree with that because, like we mentioned earlier, we're contributing to the metaverse on Bitcoin. It's called Bitmap, and it's essentially if it's every block of Bitcoin having its own 3D virtual environment. So right now there's 870,000 blocks on Bitcoin. That means there's 870,000 of these sandboxes. And then the transactions within that Bitcoin block represents the parcels that people can own individually. So think of like a square map, and that square map is divided into all the transactions within that block. And so the whole idea here is that these agents can flood this gigantic metaverse, and with the tools to build that you and I would use to build in this environment, the agents can use to also build in this environment. So the measuring stick is, can the AI agents produce stuff of value that could generate them money to create sustainability, right? So that's the task that we are continuously thinking about on our side, like from our understanding of AI agents and our background in the metaverse. We're trying to figure out all the pieces that need to combine in order to get the agents to start building content within that virtual environment. Have you heard of Bitmap?
I just heard the name, but not much details about that.
Okay. Well, in a separate call, I like to kind of introduce Bitmap to you and sort of what is happening with that ecosystem. I think you'd find it interesting because there is a component of bitmap that allows for leveraging the energy input of Bitcoin and getting that energy back out in the virtual environment. So, but we only have another minute left. So my last question to you, Landon, is I guess what's next for you for the Moss ecosystem, and do you have any releases coming out that you want everybody to be aware of?
You mean the release?
Yeah, any updates that you want to kind of let people know about, if there are any. If there's not, then
or a call to action.
Yeah,
it's because you are building like an agent framework and an ecosystem around that. It's assuming you're trying to attract the right developers, creators, contributors, whatever. Right? So AI 16Z. Their call to action is for anybody who wants to kind of contribute to like this open source AI development movement, right? So you can do that in many facets of directions, right? So what would you say is the Moss AI ecosystem's like call to action for the crypto community, how to get involved?
Yeah. So we have quite a lot of people, launch their agents, using using our AI pod, and they connect link the agent to Twitter, X platform, and right at the moment, we are improving the capability of the agents, and our AI model, and we will transfer all the capability to all the agents. And all that. So at the moment, I sense that's more than 60 agents running parallelly. And we will give the enhance all the capability of the agents. And for example, we will add more capability to generate a video or image, and the agent can generate can take a screenshots of the islands or the space in Metaverse and post in to the social media, and they can launch a drone agent to make a film or a short video and post those videos to outside this world. And more capability, for example, send emails, this kind of thing. And then all the agents will create, as I said, meaningful contents, to get more followers and more, social influence. So at the moment, I think it's better to launch those agents, since, right now we have, also growing loads, to support all the agents. And before our HYPT token officially launch your pod, inject with liquidity, we grab more HYP token. That's for.
Okay.
So right now is like the time to deploy agents, because that is like a mining.
Yeah.
You're
mining hype tokens.
Right.
And
by contributing.
Yeah.
Okay.
Yes.
Okay, good. Is there a time horizon whenever that token will, I guess, be supplied with liquidity and therefore be,
live
traded in the market?
Actually, the token can be traded, at any point. But so the community member just suggest if we reach higher market MC, marketing capacity, we can create a decent liquidity pool for HYPT, and we can start trading.
Okay. Interesting. All right, Landon, thank you so much for joining us. We really enjoyed looking into the Moss ecosystem, and a lot of the stuff that you say and you explain in your documentation, we definitely fall in line with it, and that's why we're so excited about what you're working on. And I want to thank you for coming on.
Yeah. Thank you, guys.
Yeah, and if everyone watching, all the links will be in the description. And if you guys have any questions, please let us know in the comment section below. Appreciate you guys for watching, and we will catch you in the next podcast.
Peace.